Hey, what's up, Kipsters? Hey, man, I'm so excited to be doing another lesson with you guys. You just don't know how much I actually miss teaching. Now, sometimes I do miss you guys a whole lot, but hey, we got to make it do what it do. All right, so with that being said, let's go ahead and jump right into today's lesson. Today, we're starting with geometry. Now, the cool thing about geometry is that you don't need any background knowledge, it's merely a formula. Utilize the formula and plug and chug, and you got your answer. All right. But today I'm actually going to go really in depth with it, and I want you to really understand how formulas work. Okay. So, that being said, let's go right ahead and let's jump right into it. All right. So, like I said, today we're starting with geometry. So, let's go ahead and dive right in. All right. So, I want you to take a look at this figure right here. All right. So this is what we call a rectangular prism. All right. Now, how do we find the volume of this rectangular prism? Simple. You have length times width times height. Length times width times height. Yeah. Length times width times height. L to the W, area to the H, length times width times height. Corny, I know. But hey, it helps so many people in the long run. All right. So volume is measure of how much space does something take up. Simply, the room you're in, how much space is in that room. That is the volume. When you think about a box and packing gifts, how much stuff can fit in this box or in your suitcase or in your backpack or in your binder as you all stuff it till the binders break. That's all volume. All right. And it's usually measured in cubic units. Also, cubic units can be units cubed, or you can use the exponent of 3. I'll get deeper into why we use a 3 here in a few minutes. All right? So you literally need 3 dimensions. That's why they call it 3D, 3 dimensions. Got it? Okay, maybe not. Anywho, moving on. You got to figure out how tall you are, how wide you are, and then how deep are you. Think about a pool. We got a long pool. It's wide, long, and then we figure out how many feet deep does it go. Some pools go 5 foot deep. Some go bigger than that. I don't go past 5 feet because I can't swim. Fun fact about Mr. Baker. All right. So again, let's look back at this figure. As I look at this rectangular prism, I'm trying to compute the volume. Things we already know by looking at this formula is how to compute the area. Area is length times width. Now, if you refer back to what we did back in 6th grade, maybe some 5th grade, towards the end, you'll start knowing formulas formed from other formulas. So to find out this volume, we have to start with the area. Your area is the base. It's not the bases you run on the baseball field. It's merely talking about the bottom of your rectangular prism. All right, so let's look at part 1 in its entirety. So, part 8 asks for what is the area of the base? Well, my length runs from left to right, which is 12 centimeters. And my width runs from front to back, which is 3 centimeters. Now, again, area is length times width. So when we multiply, we get 36 centimeters squared. Now, when finding area, we always use an exponent of 2. That signifies that the units are squared. All right, so now that we have discovered what the area of the base is, let's take a look at part B. The height is the side of the shape that goes up and down. When looking at the left side of the shape, my height is 3 centimeters. So now we put it all together. Base times the height equals 36 centimeters squared times 3 centimeters, which equals 108 centimeters cubed. So you just saw the question, where did we get cubed from? Like I mentioned earlier, I was going to go more in depth to it. So now let's talk about the law of exponents. So remember back in Eureka Unit 1, the very first 3 lessons we did, we learned how to add exponents together when we're multiplying the same base. So right here, centimeters squared times centimeters, when we don't have an exponent, it's an understood one, also known as our invisible one. They have the same base, so now we have to add the exponents together. So centimeters squared times centimeters equals centimeters cubed. Problem 2. We're now looking at cylinders. But just like the rectangular prism, we have to start with the base of a figure. All right? So before we can go any further, let's figure out what the base of a cylinder is. So if we're looking at the cylinder, the base is what it stands on. And looking at it, I can tell that it is a circle. Now, let's add the formula to it. When dealing with this type of formula, with volume, volume becomes volume when it has the height. So if we take away the height, we are simply dealing with the area of the base. When you add the height, you're talking about depth. That then becomes the volume. So again, from other grades, we can determine the area of the base. Now, when dealing with a cylinder, we've already said that the base is a circle. So to find the area of a circle, it will be pi radius squared. Now, oftentimes it will say leave in terms of pi, but we're actually going to solve for it today. Part A asks for the area of the base. Now, this is when it gets tricky. As you can see, I have on the bottom scrolling pi equals 3.14, and the radius is half of the diameter. But looking at the figure, it's already cut in half. So my radius equals 2, but it says to square, which is 2 squared, equals 4. Now I said a lot right there, so let's back up. Area of the base equals 3.14 times 2 squared. That gives us 12 and 56 centimeters squared. Wait, pause. I said that wrong. Good catch. It's 12 and 56 hundredths centimeters squared. Part B simply asks for the height. Now, there's not a lot that you really can do when coming to the height. You just look and find out what the height of the object is. So if we look at the left side of the cylinder, we can see that the height is 5 3/10 centimeters. Now let's put it all together and finish out this problem. What is the volume of the right circular cylinder? Well, we take the base, which is 12 and 56 hundredths centimeters squared, times the height, which is 5 3/10 centimeters, and we get 66 and 568 thousandths centimeters cubed. Well, we're going to keep it simple and round it to the nearest tenth, which equals 66 and 57 hundredths centimeters cubed.